Good evening to all. In this video, we will discuss system and its classification. Okay. First, let me know about what is meant by system. A system is a physical device in which the components are connected together and it processes the input signal. System processes the input signal and it gives us output. Y of t as output and x of t as input. Okay. So we can write y of t as the transform of input. So this is the basic system representation. Y of t equal to transform of x of t. Okay. So transform of x of t or response to the input. We can consider this as response to the input. So let me know about the classification. What are the classification? Classification of systems. So first classification is continuous time and discrete time systems. And second classification is static and dynamic systems. Static and dynamic system. And third one is causal and non-causal systems. Fourth one, linear and non-linear systems. Fifth one, time invariant and time variant systems. Variant systems. And last one, stable and unstable systems. So we know about continuous time and discrete time systems. Continuous time system is nothing but which uses the continuous time signal as the input and the input signal is processed and it gives us the continuous time signal as the output only. So discrete time system which uses the discrete time signal as the input. Then let me consider static and dynamic systems. Static and dynamic systems. Static and dynamic systems. Static, dynamic. So what is meant by static system? It is a memoryless system. It is otherwise called as memoryless system. That means its output depends only on present input. It depends on present input only. So this is dynamic system is with memory. With memory means it depends on, its output depends on past input also. Past input and future input also. Okay. So this is the difference between static and dynamic system. Let me consider one example. X of t, that is y of t equal to x square of t means if we put t equal to 0, t equal to 0 means y of 0 equal to x square of 0. If you put 1, t equal to 1 means y of 1 equal to x square of 1. That means that output depends on the present input. Here also 1, here also 1. Here also 0, here also 0. So depends on only the present input. So it is a static system. Dynamic system, let me consider one example. Y of t equal to x of t plus x of t minus 1. So if you consider this, if you put t equal to 0, y of 0 equal to x of 0 plus x of minus 1. It will become. So by this itself we can observe this output at time t depends on present input and past input. So it is a dynamic system. It has the memory with the system. Okay. So this is about static and dynamic system, second one. And then next one is causal and non-causal system. So there is a slight difference in the static and dynamic and causal and non-causal systems. that is causal, non-causal system. So for a causal system, its output depends on present and past inputs. Okay, depends on present and past inputs, but not future inputs. Okay, so non-causal, it depends on, its output depends on future inputs. Okay, so the output depends on present and past inputs. So if we consider this, y of t equal to x of t plus x of t minus 1, here it depends on present and past inputs but not future inputs. So this condition, this y of t equal to x of t plus x of t minus 1, it is a causal system. Okay, so like this. And then next classification is linear and non-linear system. Linear and non-linear system. Okay, so here for linear system, there is one principle called superposition principle. The system which satisfies this superposition principle is known as linear system. So let me know about superposition principle. That is response to the weighted sum of input signals. Okay, response to the weighted sum of input signals where A and B are factors. X1 of t, let me consider x1 of t and x2 of t as the input signals. So response to the weighted sum of input signals, that should be equal to weighted sum of output signals. So for the input x1 of t, let me consider y1 of t as the output. For the input x2 of t, let me consider y2 of t as the output. B into y2 of t. So transform of, that means response to the weighted sum of input signals, that should be equal to weighted sum of output signals. So this is weighted sum of first output signal, this is weighted sum of second output signal. So if this principle is satisfied for a system, means that system is said to be linear. If this is not satisfied, if this is not equal, means that is if principle is not satisfied, the system is said to be non-linear. That is said to be non-linear system. If a response to the weighted sum of input signals that is not equal to weighted sum of output signals, means that system is said to be non-linear system. Okay, so this is about linear and non-linear system. And next one is time invariant and time variant systems. Okay, time invariant and time variant systems. So the condition is if y of t minus t, that is equal to transform of response to the input signal. That means this output delayed by t seconds, and this is response to x of t minus t as the input signal. So if this condition is satisfied, means that is a time invariant system. Okay, if y of t minus t, that is not equal to transform of x of t minus t, that is said to be time variant system. Okay, then last classification is stable and unstable system. This is, let me consider one example only. Stable and unstable system. The oscillatory waveform is a best example for unstable system. It has the different amplitude variations and frequency variations. So it is a unstable, unbounded and unstable system. Okay. And a stable system may be of exponential waveform which has the limit. Okay. Which has the limit. Stable waveform. If waveform is like this means it is a unstable. Okay. It should have the limit for the stable system. If it is not having the limit, if t tends to infinity means that is a unstable system only. Okay, so this is about the classification of systems. In the upcoming videos, we will solve some gate problems based on this classification of systems. Thank you.